One other question directed to me was energy in esotericism. Let us now talk about that. Esoteric forms of spirituality and alternative medicine refer to a variety of phenomena. Such energy is often understood as a continuum which units body and mind. It is sometimes conceived as the universal life force running within and between all things, as in some forms of vitalism, or as doctrines of subtle bodies, and as concepts like chi, prana, or kundalini. Spiritual energy is often associated with the metaphor of life as breath. Sometimes it is equated with the movement of breath in the body, sometimes described as auras, rays, or fields, or even as audible or tactile vibrations. They are considered to be perceptible to anyone. There are training programs through various practices. You may have heard many of them. We'll get back to this subject and talk a little bit more a little later. Another question was all about magnetism. What is magnetism? Well, as far as I understand, magnetism is an interaction between two moving charges, unlike the electrical force. Relativistic effects are weak, and the speeds thereof are very small when compared with the speed of light. The average speed in which electrons move through the wire is very, very low, centimeters per second. But how can relativity be behind an impressive effect, like a car being lifted up by an electromagnet hanging from a crane? Well, matter is perfectly electrically neutral, and therefore the electrical forces cancel out reasonably perfectly, and so magnetic forces are not strong, and the electrical one is even weaker. Now consider that. On the other hand, different types of matter have a variety of useful electrical and magnetic properties. Some of them are known to be conductors, others insulators. Iron and nickel can be magnetized. Others have useful but electrical properties. For instance, dielectrics, which allow us to make capacitors with higher values of capacitance than would otherwise be possible. However, a perfect conductor, one is known as a superconductor, has no direct current, or DC, electrical resistance. Therefore, no static electric field can be found in it. But the surface of a perfect conductor is somewhat different. The reason the sun feels warm on your skin is that the oscillating fields of light waves excite currents in your skin, and they dissipate energy. In a perfect conductor, it never happens. Electrical fields cannot penetrate a perfect conductor, and an electromagnetic wave can never pass into one. By conserving energy, the wave cannot disappear. And if energy cannot be dissipated as heat, the only remaining possibility is that all of the wave's energy is reflected. That is why metals, which are good electrical conductors, are also very reflective. When they are not perfect electric conductors, they are not reflective. There are further simple observations, but let us leave them aside for the moment. Materials with a very low conductivity are insulators. Such are comprised of atoms or molecules whose electrons are strongly bound to them, and the current they create cannot be produced with their motion. A further look into Maxwell's equations will be needed at one stage to further understand matters of interest. If you recall, we talked about consciousness in terms of electromagnetism at one stage. There's also quantum brain dynamics, which we will consider. The concepts of physicists Hiromi Umezawa and Herbert Fröhlich in the 1960s need to be reconsidered. Their ideas have only recently been elaborated. According to what we learn from them, water, for instance, comprises about 70% of the brain. Quantum brain dynamics considers that the electric dipoles of the water molecules constitute a quantum field. It is also referred to as the cortical field. This cortical field is postulated to interact with quantum coherent waves generated by the biochemicals in neurons, which are considered to propagate along the neural network. Fröhlich viewed these waves as a means by which order can be maintained in living systems. There are a number of arguments about this issue. According to Jibu and Yasu, the interaction between the energy corticons of the quantum field and biomolecular waves of the neuronal network produces consciousness. That sounds interesting. Theorist Vitiello proposes that the quantum states produce two poles, a subjective representation of the external world, and also the internal self. According to him, consciousness is not in either the external representation or the self, but the opening of the self to the representation of the external world. In a 2002 issue of the Journal of Consciousness Studies, the electromagnetic theory of consciousness faces an uphill battle. We must remember that scientific study of consciousness has only recently started to gain some acceptance as a scientific discipline. The field theories of consciousness have not been widely discussed, other than for a few theories we have just touched upon a little. Locating consciousness in the brain's electromagnetic field rather than the neurons neatly accounts for how information located in millions of neurons scattered through the brain can be information unified into a single conscious experience. In truth, the information in the electromagnetic or EM field. Perhaps this way, EM or electromagnetic field consciousness can be viewed as being joined up information. Confused? Hopefully not. Other EM field theories disagree as the role of the proposed conscious EM field on brain function. According to theories we looked at, the brain's global EM field or electromagnetic field modifies the electrical charges across neural membranes, thereby influencing the probability that particular neurons will fire, providing a feedback loop which drives free will. According to other theories, there's no necessity or necessary causal link between the consciousness or conscious electromagnetic field and our consciously willed actions. If this theory is correct, it can be counterproductive to the process of creating artificial intelligence. The theory of electromagnetism, also known as classical magnetism, was created by various physicists during the 19th century, culminating in the work of James Clerk Maxwell, who unified the developments into a single theory and discovered the electromagnetic nature of light. One of the peculiarities is that it is very hard to reconcile with classical mechanics, but interestingly, it is compatible with the special relativity. According to Maxwell, the speed of light in a vacuum is a universal constant. It depends on the electrical permittivity and magnetic permeability of free space. This is contradictory to Galilean invariance. But the two theories can be reconciled, and that is to assume the existence of a luminiferous ether through which the light propagates. Many efforts fail to detect the realism of such ether. Albert Einstein has solved the problem with his special relativity. It has replaced the ancient kinematics with a new theory. The relativity theory depicts that in moving frames of reference of a magnetic field, it transforms to a field with a non-zero electric component and vice versa. It shows definitely that there are two sides of the same coin, thus the terminology of electromagnetism. I'm not going to be too cruel with you. But let me ask you this question. What does electromagnetism do? How does it work? What about thunder and lightning? Is it electromagnetic? And what can you use it for? Do you realize that you know more about electromagnetism than you think? It's a name scientists give. Remember, we spoke about this issue. Radiation is energy, which travels and spreads out as it goes. Visible light comes from the sun or your electrical lamp. Radio waves originate from a radio station and are two types of electromagnetic radiation: microwaves, infrared and ultraviolet light, X-rays and gamma rays. Just think about them. Hot and energetic objects and events create high energy radiation that cools objects. Extremely hot things and particles at very high speeds create X-rays and gamma rays. Radio waves come from a radio station emitting into the air so that you can listen to Madonna, Justin Timberlake and others. But there are also other things which emit radio waves, such as the stars and nebulae in space. You cannot listen to them or dance to their music, but you can learn and discover a lot of other things through them. Radio waves, visible light, X-rays, and all other parts of the electromagnetic spectrum are just the same thing. Electromagnetic radiation. Electromagnetism is a science explaining the forces which occur between electrically charged particles. These forces are explained in electromagnetic theory using electromagnetic fields. Electromagnetic force is one of the four fundamental interactions in nature. The others are strong interactions, weak interactions, and the gravity. The Greek word electron literally means amber, like the electrostatic phenomena. Philosopher Thales has spoke of its properties for the first time, as well as magnetes, or magnet, like the magnetic stones discovered in the Greek city of Magnesia and Lydia in Asia Minor, or Anatolia, if you like. An encyclopedic explanation of electromagnetism is the interaction responsible for almost all phenomena one faces every day of our lives. Ordinary matter takes its form as a result of intermolecular forces between individual molecules in matter. Electrons are always observed being attracted by electromagnetic wave mechanics into orbital around the atomic nuclei to form the atoms. They are the building blocks of molecules. Now, electromagnetism manifests as electrical fields and as magnetic fields. Although both fields are different aspects of electromagnetism, they are closely related. When we change the electrical field, we generate a magnetic field. Therefore, when we change the magnetic field, we generate an electrical field. This is what we call electromagnetic induction. This, in reality, is the basis for electrical generators, induction motors, and transformers. Electric fields and magnetic fields are convertible with relative motion. Electric fields are the cause of electrical potential, as with the voltage of a battery, and the cause of electrical current, as the flow of electricity through the flashlight, whereas magnetic fields are the cause related to magnets. The theoretic implications of electromagnetism led to the development of Albert Einstein's special relativity in 1905. In the beginning, electricity and magnetism were considered to be separate forces, but when James Clerk Maxwell published the treatise of electricity and magnetism in 1873, in which he described the interaction of positive and negative charges being regulated by just one force, it completely changed the old viewpoints. Experiments have been conducted, and four main effects have been discovered from these interactions. 1. Electrical charges attract or repel one another. 2. Magnetic poles attract or repel one another in similar ways, and they always present two poles, positive and negative. 3. Electrical current in a wire creates a circular magnetic field around it, and its direction, clockwise or anti-clockwise, depends on that current. 4. A current is induced in a loop of wire. When it is moved towards or away from it, its direction depends on that of the movement. During 1820, Hans Christian Ørsted noticed that his compass needle deflected from magnetic north when current from a battery was turned on and off. He then declared that magnetic fields radiate from all sides of a wire carrying a current, like light or heat. There was a direct relationship between electricity and magnetism. Soon he published his findings. electric current produces a magnetic field as it passes through a wire. The French physicist André-Marie Ampère developed a simple mathematical form representing the magnetic forces between current-carrying conductors. Ørsted's discovery represented a major discovery towards a unified concept of energy. This was observed by Michael Faraday, extended by James Clerk Maxwell, reformulated by Oliver Heaviside and Heinrich Hertz, and become one of the key establishments of 19th century physics. It led the way towards understanding the nature of light. We need to consider here that light and other electromagnetic waves take the form of quantized, self-propagating, oscillatory magnetic field disturbances called photons. Also, different frequencies of oscillation give rise to different forms of electromagnetic radiation. Radio waves at the lowest frequencies up to visible light at intermediate frequencies, and to gamma rays at the highest frequencies. In 1802, an Italian legal scholar, Gian Domenico Romagnosi, also examined the relationship between electricity and magnetism. The other fundamental forces are the weak nuclear force causes certain type of radioactive energy. This is usually studied in particle physics, where electro-weak interaction is mentioned, and which is unified in description of two of the four known fundamental interactions of nature: electromagnetism and weak interaction. The strong nuclear force binds quarks to form nucleons, and binds nucleons to form nuclei, and thus the gravitational force. All other forces, for instance friction, are ultimately derived from these fundamental forces, and the momentum is carried by the motion of particles. The electromagnetic force is the one responsible for all the phenomena we encounter in our daily lives above the nuclear scale, with the exception of gravity. All the forces involved in interacting between atoms can be explained by the electromagnetic force acting on the electrically charged atomic nuclei and electrons inside and around atoms. Altogether, how they carry momentum by their motion. We experience pulling and pushing in ordinary material objects that come from the intermolecular forces between the individual molecules in our bodies and those within all other objects. This includes all the chemical phenomena as well. The effective force is generated by the momentum of the electrons' movements, and they move between interactions of atoms, each of them carrying momentum with them. The behavior of matter at the molecular scale, including its density, is determined by the balance between the electromagnetic force and the force generated by the exchange of momentum carried by the electrons themselves. However, the most important subject in my mind is electromagnetism and consciousness. Let us talk about that. According to some scholars who are theorists, consciousness can be described as an electromagnetic phenomenon. In one theory, EM, or electromagnetic field theories of consciousness, suggests that consciousness results when a brain creates an electromagnetic field which has features which meet certain criteria. Susan Pocket and J. McFadden have proposed, and William Vitale criticized all those theories, but they have not rejected the idea that consciousness may be an electromagnetic phenomenon. Some other theories consider quantum mind theories of consciousness. These included quantum brain dynamics, or QBD. However, almost all quantum mind theories other than QBD do not consider consciousness as an electromagnetic phenomenon. Alexander Finkelhurt, like a few others, developed operational architectronics framework of brain-mind function. McFadden has proposed that the brain's electromagnetic field creates a presentation of the information in the neurons, but also many studies and experiments conducted pre-20th century and debated over presented that conscious experience correlates not with some of the neurons firing, but rather with the synchrony of that firing. McFadden considered the brain's electromagnetic field as arising from the induced EM, or electromagnetic field, of EM field fluctuations, or neurons. In this theory, synchronous firing of neurons amplify the effect of the brain's electromagnetic field fluctuations to a much greater extent than would be possible with the unsynchronized firing of neurons. This would influence the brain in several ways. A redistribution of ions could modulate neuronal activity. Neuronal firing is also debated over that is sensitive to variations as small as 1 millivolt across the cell membrane, or there is another involvement of a single ion channel. A transcranial magnetic stimulation is considered to demonstrate that weak electromagnetic fields can influence the brain's activity. McFadden proposes that the digital information from neurons is integrated to form a conscious electromagnetic information field in the brain. Therefore, consciousness is said to be the component of this field being transmitted back to neurons, communicating its state externally. Thoughts are seen to be electromagnetic representations of neuronal information, and the experience of free will in our choice of actions can be our subjective experience of the conscious electromagnetic information field acting on our neurons. Neurons generate patterns in the EM, or electromagnetic field, which modulates the firing of particular neurons. The only conscious agency considered here is that the field, or its download, to neurons is consciousness, and the processes of the brain are driven by the deterministic electromagnetic interactions. Susan Pocket has a more advanced theory. She suggests that the EM, or electromagnetic field, comprises a universal consciousness which experiences the sensations, perceptions, thoughts, and emotions of every conscious being in the universe. Unlike McFadden, she does not consider the field as causal for our actions. I hope we have been able to answer some of those questions of yours. Thank you for spending this time with me. I am Suren.